Hi, I am Gianluca Mancusi from the University of Modena and Reggio Emilia, and I'm going to present our ICCV 2023 paper, TrackFlow, Multi-Object Tracking with Normalizing Flows. Multi-object tracking, commonly shortened to MOT, is a critical process in various applications, such as autonomous driving and surveillance. It involves the continuous detection and identification of objects in a video stream. Within this field, one of the dominant paradigms we explore is tracking by detection, where bounding boxes are computed frame by frame using a detector and are subsequently associated with existing object tracks. While we often rely on the visual domain to distinguish objects, it is important to remember that it is just one piece of the puzzle. Today, we have access to a vast amount of multimodal data, and this diversity can significantly contribute to the association cost computation. This includes data such as pose information, depth segmentation maps, and even thermal data. In our work, we exploit the large multimodal synthetic dataset ModSynth. Over the years, various methods have been developed to compute the association cost when dealing with multiple types of information. For instance, DeepSort combines motion and appearance by computing a weighted sum of the Mahalanobis distance for motion and the cosine distance for appearance. In another approach, called FALF, authors reframe the cost as the probability that a given detection belongs to a specific tracklet. However, this method comes with the need for a meticulous tuning of hyperparameters using a separate holdout set. Additionally, it assumes that the costs from different sources are independent, which may not reflect the real-world dynamics accurately. In our case study, we're dealing with a situation where we need to couple 2D and 3D data, where 3D data is the distance of the target from the camera. To estimate the distance of each target from the camera, we designed this synth. However, the accuracy of the distance prediction can be affected by occlusions. To address this issue, we enabled our model to analyze past frames, allowing it to determine when an object was not occluded. For this reason, our model takes as input a clip, including the current frames and previous ones. Then, a detector, for example YOLO-X, is employed to extract target bounding boxes of the last frame of the clip. To preserve fine-grained visual details, our model uses a ResNet 34 FPN backbone. At the end of the ResNet, we incorporate a convex TM for clip processing. Next, we concatenate the feature maps, and then, for each target bounding box, we employ a ROI pooling operation to extract its feature representation. Finally, we use an MLP regressor to predict the distance and its associated aleatoric uncertainty. To ensure that we do not assume independence in the cost computation and to directly estimate the joint distribution, we build a normalizing flow model, namely TrackFlow. Normalizing flows offer a probabilistic framework for modeling complex data distributions. With our model, we can compute the association cost between the track and the detection by providing it with the 2D and 3D displacements, x, y, width, height, and the distance from the camera. This is also conditioned on the track temporal motion and on the entire scenario-level features extracted by using clip on the entire frame. We train TrackFlow to estimate the density of correct associations using data from the ModSynth training set. In summary, our model takes as input the displacement between a track and a detection in terms of their 2D geometrical information, along with the distance predicted by this synth, and it is also conditioned on the previous track motion and the clip visual features. We evaluated our approach on multiple datasets, including the ModSynth test set, which we divided into 3 subsets: easy, moderate, and hard. Our results consistently show significant improvements in terms of HOTA and IDF1 compared to the state-of-the-art trackers, achieved by integrating our association method into these trackers. Thank you for your attention, and we invite you to join us for a scientific discussion at the ICCV conference by visiting our TrackFlow poster.